First of all, welcome to this training. This event is called Buildspace for Flood Resilience, Predict, Plan and Protect. I remind you that this webinar is being recorded and we may share also the recording later. My name is Lizeth Lopez. The goal of this training is to introduce and give you, of course, an overview of Buildspace backgrounds, objectives, and potential opportunities for replication. In particular, this specific training will present the features of Pilot 4 together with the technologies used in the development of Service 5, which is urban flood resilience. So before we start, I would like to give you an overview of the agenda. If we can go to the next slide, please. So for this event, we have planned many short sessions. These sessions including discussing about the challenges regarding flood resilience in Ljubljana. Then we will give a short the goal methodologies of urban flood analysis and resilience. We will have the chance to grasp a bit about the benefits and increasing of replicability in other European contexts. And finally, the last part of the session will be regarding a demonstration of Service 5 and some questions and answers that you may have regarding the use of the service or any of the replicability. So I kindly ask you to send us your questions or your doubts through the chat. If not, we will have a question and answer session at the end of the training to answer these in a more one-to-one question and answer. So before we start, of course, I would like to give an overview of the framework in which this training is created. So if we go to the next slide, please. I will talk about Buildspace. Buildspace is a 3-year project which is supporting the Green Deal objectives. We are a consortium of 14 partners, and the goal of Buildspace is to couple territorial data from buildings with aerial images from drones equipped with thermal cameras and location annotated data from satellite services. The donor of the project this is an Horizon project. The budget is of over 2 million and the time frame is 3 years, which started in February 2023 and is gonna finish next year in January. If we go to the next slide, please. So Buildspace is a platform, as I said, that will allow the integration of this heterogeneous data and will offer 5 decision support tools, which we denominate services. These services will apply from building to urban scale stakeholders in different sectors. Could be construction, renovation, urban planning, city authorities, energy, as well as policymakers and researchers. So why are these Buildspace services so relevant? Because lately, as we have seen, urban areas face increasing climate changes like heat waves or floods. We believe decisions must be informed by accurate and spatially aware and scalable data. For overview, we can go to our next slides, and I would like to introduce our speakers of today. So today we have 3 special guests who are gonna guide you through the training and through the service. Our first, Petra Pergar. Petra is an expert in urban economics, circular economy, and urban flooding. She co-authored the flood damage assessment methodology and played a key role in simplifying the application for Buildspace Service 5. As director of the municipality of Moraxec, part of the Ljubljana region, Petra brings hands-on experience with the everyday challenges of sustainable spatial planning and direct engagement with the stakeholders on the ground. She represents in this sense to IMSI. Our second speaker is Tis Maes. Tis is a geographer and project manager at the Belgian Nazca Maps. He leads the Buildspace project on behalf of Nazca, working close with a talented team of developers. Together, they design and build the application for Buildspace Service 5, translated complex data into practical tools for urban resilience. So he's on behalf of Nazca. And for our third speaker, Cristina, she's also part of IMSI. Cristina is a co-founder of IMSI with a background in engineering and design. She has an extensive experience in spatial development projects, particularly those related to water. Since 2012, she has been committed to creating sustainable solutions for stormwater management and urban flood resilience. She's also the developer of the blue-green factor methodology used in Buildspace Service 5. So these are our special guests today. And I think with this, we can go over the training, and with nothing else to add, I will just give the floor to Petra to start the training. And we can go to the next session, please.
Hello, everyone. The city of Ljubljana, the capital of Slovenia, is located between two rivers, the Ljubljanica and the Sava. The urban and agricultural area between the two rivers is home to nearly 500,000 Slovenian residents. The Ljubljana urban region is participating in the Buildspace project as a pilot city for the urban flood analysis and resilience Service 5. This pilot's main objective is to apply a data-driven, user-friendly approach that will enable to assess expected flood damage to buildings and to define flood vulnerability hotspots. Hydrological impacts of blue-green infrastructure will be visualized and defined using advanced analysis and visualization tools. Next slide. Because of its vulnerability to flooding, Ljubljana has a long history of implementing various flood protection measures. But still, many parts of the city remain heavily threatened by floods. Although there are ongoing investments in structural flood protection measures such as dams, reservoirs, and river restoration, urban floods will remain in some parts of the city. The reason is urbanization, with reduced permeable surfaces and low drainage capacity. Next slide. Ljubljana faces several challenges in terms of flood resilience, particularly due to the combined pressures of increasing urbanization and climate change. The key challenges that we need to deal with: urbanization and land use change, aging and inadequate infrastructure, climate change impacts, topographical and hydraulical constraints with low-lying flood-prone areas and its river network complexity. And of course, adaptation and resilience planning is something that we need to take very, very serious. Next slide. Urbanization and land use changes leads to loss of permeable surfaces, increased stormwater runoff, and according to settlement, development near or within flood-prone areas restricts natural river flows and increases the risk of flooding. Aging and inadequate infrastructure. We have old drainage systems. Many parts of Ljubljana rely on drainage systems that were not designed for current or future rainfall intensities. We still have combined sewer systems that can overflow during heavy rain, and that leads to both flooding and pollution events. And we have limited retention capacity. Existing infrastructure lacks the capacity for adequate stormwater retention or delayed discharge. Next page. Impacts of climate change in Ljubljana are, due to recent measures, pretty serious. And increased intensity and frequency of rainfall is already here. More frequent and intense storms leads to flash flooding, which the current urban infrastructure struggles to manage. Its rising temperatures can contribute to more intense precipitation events and more often drought flood cycles. And changes in timing and volume of river flows complicate flood risk planning. Thank you.
So, as Lisette said during the introduction, the service fits within the Buildspace project. So I wanted to give a small overview of how Buildspace is structured, so that we get a bit of a zoom out and an idea of the structure. So Buildspace basically consists of two main parts. First, there is the Buildspace core platform, and that's quite an important part. So the core platform has been developed to assist basically the services in getting access to all the complex and heterogeneous data that exists. So the core and external service layer of the core platform, it takes all the data from, for example, Copernicus, ECMWF, EGNS services and sources, as well as all external sources, tries to harmonize this and creates very homogeneous APIs that are structured within a data federation layer, and that service all the different services with the data that they need. And this process makes it a lot easier for all the services to get all this data and actually work with it. Beside the data part, there's also some front end developed within the core platform, which allows for user management, so that people who want to access services can access the services with different logins, with the same login to the different services, as well as a data discovery platform where users can also upload their own data themselves that can be used within the services. Then besides the core platform, so yeah, we also have the Buildspace applications. There are 5 applications which have been developed, which are grouped into groups. First, there is the building services, which focus on digital twins, and as well as then the city services, where there are 3 services focusing on environment climate scenarios, on urban heat, and then service 5, which is the service we are presenting today about urban flood analysis and resilience. I think this is the most important one, so we can continue to the next slides, and I'll go back to Christina.
Hello, welcome from my side too. While colleagues Petra and Tis presented the project framework, I will introduce our Service 5 Urban Flood Analysis and Resilience Service with its aim. The main objective for Ljubljana pilot is to apply, as already Petra pointed out, a data-driven, user-friendly approach to assess expected flood damage to buildings and flood vulnerability hotspots with hydrological impacts of blue-green infrastructure using advanced analysis and visualization tools. Also integrating Earth observation data. Next, please. The first methodology on which our service is based is the flood damage analysis methodology. It was developed within the framework of national projects for Slovenia. The base for our first use case and most included more than 400,000 points, 100,000 lines, more than 1 million polygons, and more than 70 equations. And then the values used in our tool were summarized according to methodology developed for Slovenia with some simplifications required for the purpose of developing the application. So the damage to building structures and equipment, human health, cleanup costs and damage to vehicles are considered. Next, please. Flood damage is defined as expected damage in a specific area for a specific flood event. It is a product of extent, the size of special components in a selected area, such as area of invaded buildings, exposure, like as a likelihood of the presence of vulnerable elements. Then the next is vulnerability, as the probability of structural damage to a component in a specific flood event. Event intensity, and the last is the value that represents the market of social value of special components in the selected area. Next, please. The main barrier to using this methodology was that it required a technical expertise. And as part of the Buildspace project, the method was simplified in such a way that it was able to use as a web application in a way that all expected damage was tied to buildings. And both the basic method and the required application are based on the import of spatial data related to floods, flood reaches as flood maps and polygons. The method of calculating expected damages also allows for the consideration of full depths and extending the application using land use categories from Urban Atlas. For each Urban Atlas class, a cost value per square meter has been calculated based on the methodology for Slovenia for different damage classes. Next, please. And there is a quick list of input data for flood damage analysis. If we look at them together, as administrative national data, we have building data, public infrastructure data, registries, spatial units, land use, and water bodies. As administrative data, we have also flood map extent from flood models as offered scenarios of flooding area. As Copernicus service data for extending to the whole European content, we have lead cover data from Urban Atlas cover. Then we have as model result data, flood damage values, like attributes connection to the building type. And the climate change scenarios and adaptation measures scenarios for this use case have been provided by extending the current floodplain area or shrinking it, because we don't have this data for Ljubljana yet, but we wanted to provide the possibility to offer this data later and include it in analysis and visualizations. Next, please. With this background, we want to present the first use case of flood damage estimation running in river flood damage estimation mode, as Tess will demonstrate after, that calculates and visualizes the expected flood damage to buildings to identify flood vulnerability hotspots in terms of flood damage. Actually, flood damage estimation can be used for not only for river flooding, but also for flooding from other sources. If you upload floodplains from other types of flooding, the methodology can be used to calculate the damage as well. Yes. Now let's move on the other methodology used in our service. We know that blue-green infrastructure as part of green areas affects the runoff in such a way that it reduces the peak of the runoff, as shown in the graph. Next, please. The 330-300 norm on accessibility of green spaces, which you are probably all familiar with, is very illustrative. Everyone can imagine very quickly, for example, what it means to see trees from a window. However, as green spaces are closely linked to water, not only in the direct use of blue-green infrastructure, we developed a simple methodology to visualize the 5 millimeters reference rainfall runoff principle as a runoff norm for urban areas. Next, please. The methodology is based on STS curve number method rainfall runoff calculation, where PE value represents approximate amount of runoff from a rainfall event in a particular area. Runoff value actually depends only on the runoff values and CN values. For rainfall values indicated by PIN, we use simulations for current statistical rainfall events and IPCC climate change scenarios, RCP 2.6, RCP 4.5, and RCP 8.5. And the dimensionless CN values are given by, firstly, by CN map for Ljubljana open area for current land use scenario extracted from the literature, and new CN values for blue-green infrastructure measures scenarios. Next, please. For climate change scenarios, we give the recipe scenarios RCP 2.6 like most optimistic scenario, recipe 4.5, and recipe 8.5 like most pessimistic scenario as modeled projections of possible trends in atmospheric temperature increase and the resulting in maximum daily precipitation values, as shown in the table, as recalibrated outputs for SCP local scenarios provided by Slovenian Environment Agency for the pilot area. Next, please. CN values for CN map for Ljubljana urban area for current land use scenario, we extracted from the literature and tied to urban atlas classes. Next, please. Blue-green infrastructure measures scenarios are incorporated by new CN values extracted from the literature. First, blue-green infrastructure scenario implements green roofs on all existing buildings. Second scenario implements blue-green infrastructure on all grass areas. There is used weighted average CN of all blue-green infrastructure except green roofs and permeable pavements. And the third scenario implements blue-green infrastructure on all unpermeable pavings. There is used weighted average CN of all blue-green infrastructure, including green roofs. Next, please. And there is also a quick list of input data for flood urban runoff analysis. Actually, the same as administrative national data. Also, as Copernicus service using Earth observation data is used urban atlas coverage. CN values are used like model data, like attributes connection to urban atlas land use classes. Climate change scenarios is provided from Cordex projections for precipitation values, also as Copernicus service data using Earth observation. and adaptation measure scenarios like blue-green infrastructure retrofit scenarios. And the last one, please. So with this background, we want to present the second use case of urban runoff simulation running in flash flood hotspot simulation mode. And it simulates rainfall runoff to identify urban flood vulnerability hotspots with hydrological impacts from blue-green infrastructure. Thanks. So this, I give you the word.
Yes, thank you, Christina. So as part of Buildspace, one of the most important elements to keep in mind is that we create a solution which is applicable in the whole of Europe. So we always try to make choices that make that possible. An important one, it was already mentioned by Christina, is that in the calculations, we use a European source, or a Copernicus source, which, as you can see on the map, is available in the whole of Europe, even outside of the European Union. And we use this as a source in our calculations if we're looking at land use clauses. So the Urban Atlas cover is a very good product for that. So it's calculated every 6 years. At this moment, there is the version of 2018 is in the application because the version of 2024 is a bit delayed, so it should come around summer, and we will of course update it then. But the Urban Atlas, so yeah, it's a very detailed land use classification system, providing with about 25 clauses, and it's available in 788 urban areas in 38 European countries. According to Copernicus itself, so the areas they've included are all urban areas above 50,000 inhabitants, which gives us really the possibility to have a very large area that we cover with our solution. And then next slide, please. Another thing that we included to increase the replicability for other users is a possibility to create custom parameter sets. So as Christina just explained in both the damage estimation mode as well as in the urban runoff mode, there are certain parameters that are used. Now, as a standard parameter set, which we provide, so you can use those if you want to, we calibrated the parameters for the Ljubljana pilot site at this moment. But we allow you to basically change every single parameter. As an example here, for example, you have the damage values per square meter. So for each Urban Atlas class and for each damage class, we give you the possibility to change how much damage a flood would do per square meters in euros. As you can see on the screenshot. And we do a similar thing for the runoff calculation, where we allow you to change the infiltration values for each urban class. So we give you that possibility to change it and save this parameter set, and it will also be saved to your profile. So which means that you can reuse it later if you want to create, for example, one for your own area where you have more detailed information for. And then the next slide. Yes, this is the last one, which is quite an important one. It's important to mention that this is still in development. It is coming in the next 2-3 weeks. At this moment, as you will see in the demo in a few minutes, we have included flood extent areas and building layers for the Ljubljana urban region, which is our pilot area. But we are planning at the short term to allow users to upload their own flood extents as well as building layers, which will then allow you to actually really use the application on every single area in Europe. How we plan to do that is that you either have the option to just upload your files from your desktop, just from your local file explorer, or we use the core platform we just mentioned earlier. So there is also a data management system set up there, where users can upload data themselves, make it public, make it private, and so on. And we will allow you to actually take data from the core platform as well. But so this is still in development. I cannot show it yet, but it will come really soon. And I think if the next slide is already the demo, if I'm correct. Yes, so I will take over the sharing of the Zoom meeting, so I can showcase you the demo. Okay, so I think it should be visible. I hope. Yes, perfect. Okay, so I will take you through in a few steps through the application to showcase a bit what it can do, what choices we've made. So if you would go to the application, you will first have to log in. You can sign up yourself through the platform as well. I of course already have login, so I've just entered my details and I will log in. This is really important to remember, because the login also means that everything you do, all the results you create, all the choices you make, the parameter sets you create, are all saved specifically for your profile. So that means that if you would log in again, or also from another device or so on, you will get all your data back, and you can just start again where you left off the last time. When you log in, you will get this little pop-up, which allows you to choose which mode you want to be in. So as said, we have two modes, one for the flood damage estimation, as well as for an urban runoff simulation. I will first go to the flood damage estimation as for the first part of the demo. So if you click select, you are now in the flood damage estimation. You can see it on top of here as well, in which mode you're in, and you can choose to change modes also from here if you want to. See, the map is logged in. We have included a search possibility to navigate to every city you want. I will now use Ljubljana, our pilot area, to zoom in. And you can see that the map will navigate there. How is it structured? Actually, everything is structured around the data panel, which you can see here on your left. First part, which is important here for the flood damage estimation, is that we have already, as said, preloaded some flood extents. So the upload I was talking about for your flood extents will be added here. So here you will be able to include your own floods as well. But we provide you with some first floods, which are now calibrated for Ljubljana. As you can see, if you activate them, they load in quite fast. And you can see which flood is visualized, which is now a 500-year flood. There is a little button here, change flood scenario, that if you click it, it will open a new pop-up that shows the different kinds of flood we provide. So for now, we have 3 floods, a 10-year flood, a 100-year flood, and a 500-year flood. And then we have the scenarios, which Christina also talked about. So we simulate either an anti-flood measure scenario, where we assume that certain flood measures have been incorporated, which will decrease your flood extent buffer by 50 meters. Or we include a climate change scenario, where we assume that the buffer will expand with 30 meters. For example, I will choose this one now. You can already see in the preloaded map what the different flood would look like, and I put confirm, and the new flood has been loaded in. Next, we have our land use features. Now, the land use features are really the base of our calculation. So here we have 2 options. Either we have the urban atlas cover, which is what we said before. So this is a Copernicus service, where we have a very detailed, I will zoom in maybe, and then if the internet wants to follow, yes. We'll see the detail that it's really classifying. So it's really, really detailed. If you over here, you can see all the different classes, or about 25 of them that we support. As a user, you also have the possibility to change the opacity of your layer. The other option is the building data. So here we again have a preloaded building set for Ljubljana, but the idea is again that you can upload your own building set as well if you would like that. Okay, extra features on this base map, which might be interesting to have or to use, is of course on map controls, which is allow for zooming as well as changing your direction, as well as a background selector. Here we have two options. One is satellite view, which, if it would be interesting for you, uploads a satellite image for your area. It's available all around the world. A second one we have is local boundaries, which might be handy for navigation. This means that we load in different boundaries for the area you're in. So, for example, for Slovenia, we have all the Slovenian municipalities. And here you can change to another country if you want. So if you're, for example, in neighboring Croatia, it will load in all the municipalities for Croatia. So this can just maybe help as a kind of navigation tool. I will deactivate them again for the moment being. So this is a bit the base map. Now the next step, of course, is creating your damage layer, which is the most interesting part, of course. They can do that either by clicking the plus right here, which is in your results part by flood damages, or you can click the big button right here. If you click it, it will go into the creation mode, let's say. We need some kind of parameters for you to decide, for you to fill in, before we can do the calculations. First of all, you need to enter a name, and this is the name that will be, I will put in my damage layer, which will be used to save the result layer and also in your personal profile database, which means that if you log in again, you will see this layer again. Here, you can still change your flood scenario if you would like to. So now it just enters whatever is visualized on the map. Next, you need to select an area of interest. That's important because the calculations can be quite heavy, so we cannot calculate it for the whole city. So that's why we ask you to actually draw an area of interest within where the calculations will happen. Now, again, your areas are saved to your profile. So, for example, I've drawn a little area before, and as you can see, I can just select it here, or I can choose to draw a new one. For example, I've selected now this area that I've drawn before. Next, you need to select your land use features. Now, that means that we can either do the calculations on the Urban Atlas cover, so a land use map, or we can do the buildings. So that's up to you what you want to decide. I will now try the Urban Atlas cover. And what we do is that we do an API request to the Urban Atlas cover and get all the land use classes that are within your area of interest. If you hover over them, you will see which they are. And you can decide yourself if you want to include all of them in your calculations, or if you say, no, I'm not really interested in, for example, the forest and semi-metro areas, you can deactivate them and they will not be incorporated in your calculations. I will just keep everything active for now. Two extra things have popped up that might be interesting. If you choose for the Urban Atlas cover, those are not available for buildings at this moment. One is a flood height parameter. So for buildings, we just use the flood extent. For the Urban Atlas cover, we also give you the possibility to change the flood height. And depending on the flood height you use, certain damages will change, which of course makes sense. So the standard flood height we use is 62 centimeters. But if your flood is really extreme and you have a flood of 2 meters, it will, of course, have a large effect on the amount of damage that's created to infrastructure, to buildings, and so on. So if you want to change it, you can. I will just leave it on 62 centimeters for the moment. And lastly, that's your parameter set. So we have the standard parameters, or you can create a new parameter set. I will quickly go there to show how it looks like. This is the screenshot that we showed before. So here you can choose to change the values, for example, for the class continuous urban fabric. For my area, I know that the building structures are really expensive and are really modern. I want to increase the value of not 280 euros per square meter, but I want to increase it to 400, 500 euros per square meter if you want to. And then you can save it and select it. I will just use the standard set one, so I will cancel this again. But if you would save it, it will be here in the list and you can choose it. If everything is set in, I will click calculate, and then now it will start calculating. Might take some time. Yes, there it is. So now you can see the result. So it's immediately loaded into the map. What do we see? It has also been added here to your flood damages group. So this is a bit your result group. And you see I have created one before already. You can choose to rename it or delete it if you would like to. It's now in here. We see it on the map here, and we have now chosen in the beginning to use certain classes from low damage, middle, high, very high, depending on the values that have been provided, have been calculated. These classes are continuous. So if you would change, for example, I would change them other layer, you see some colors might have changed, but the classes are exactly the same. So it's always the same classes that have been used. But let's say if you want to have a more detailed understanding of what has been created here, and you want to show really the difference within your calculation, you can also click on this little button here, which goes to cost. And then you will have a continuous scale that just will take the lowest value in your results to the highest value and color it this way, which means that the coloring might be different depending on the layer that you've chosen. So it will just really have a continuous scale, and it will really assist you in understanding the local varieties within your area of interest, within your result layer that you've created. Okay, what else that's interesting? There's a little blue button here that's popped up. If you open it, it will open a data panel. So the map will move a bit up front, and you will see a more detailed look here of the different of the things you've created and all the values you've created. On the left, you can still switch to different layers if you would like to, so you don't need to do it through the core platform, to the layer selector, I'm sorry. But you can also just do it here. You will get some general info, so the size of your area, the number of features, so this is the number of classes that were in your area. There were 61, of which 47 are flooded. And we have calculated that in your area, there will be a total damage of about 28 million euros. So this information you get here. And then here on the right, we have made some extra visualizations in the form of both tables and graphs. First of all, we show the cost per damage class. So we calculate different kinds of costs. We calculate damage to buildings, we calculate damage to equipment, to vehicles, for example. What are the cleaning costs, possible human health costs, and so on. So we have different kind of damage classes. They are represented here in a graph, and the same information is represented in the tables. You can see everything here as well. And then if you zoom down, we get another kind of visualization, which is the different land use classes. So here you see that in this area, which is a very densely urban area, that basically 99% of your damages are in the group of artificial services, and that everything else is quite small. If you want to have more detail and you want to have every single class, that's also possible. You can click this button, and then you see the graph and the table will change. And then you will get actually every single urban atlas class and how much damage there is estimated. Good. What's an extra interesting feature that we would like to show is there's still a button here, which is called Compare Scenario. Compare Scenario allows you to compare two different damage layers. There is one condition, is that the two damage layers are within the same area. So you cannot have two different areas and compare those. We only allow for comparison for the moment within the same area. So what have we done? So we have our damage layer 2. As you can see, it has been selected as scenario 1, and it's shown on the left. And here you can select your other scenario that you want to compare it with. So there was another layer that I pre-created. It's called damage layer 1. If I click on that, you will see that it's loaded in. So what do we have here is that we have a comparison both in the table, let's say in a data panel, I'm sorry, as well as on the map. I will maybe quickly turn off the layers because it allows you to see what this slider does. The slider actually shows you what the different flood, for example, has been chosen. You can see that the scenario on the right has less of a flood than the scenario on the left. If you would like to change it from position, that's possible by clicking here, and it will just change the two scenarios 1 and 2 from the side you want to choose. I will activate it again because that's quite interesting to see as well, is that here you can also see that certain areas, as you can see, went from yellow to orange or from orange to red. So you see that there's actually a difference between the two. The two scenarios also shown here again with the same visualizations in the table form as well, in the graph form as well as in the table form, where you can very clearly see that changing the two scenarios, where one had no climate change incorporated and one does have climate change, you see that, for example, the building damage will rise with 27%. So we have this kind of visualization, this kind of comparison included. If you click the cancel scenario comparison, you will get out of the comparison again. So this is largely the flow for the flood damage mode. I will go to the hotspot mode as well, which is largely the same, so it will not take too long anymore, because I see we're running a bit behind the schedule. So what's the difference? Not that much. The latest feature here is, again, you can create your flood hotspot layer. So here I will again need to give a name. I will put my hotspot layer, for example. Now, here I want to focus on my buildings more, so I can activate them here if I want to. And for example, I would like to do an analysis of the runoff in this area. Here, I have not preloaded any areas yet, so I can just draw a new one. You can choose to draw a circle, a square or rectangle, as well as any free polygon you'd like. So, for example, I will do it like this and put it, if it wants to activate, yes, there we are. Well, it's called Novo. So, and confirm. Now, what's interesting here is that we have to select a rainfall scenario that which we like to simulate. Either you can just enter any value in millimeters you want. So we're simulating a 15-minute rainfall event. Now, if you're not that keen or not that familiar with rainfall quantities, we also included this extra functionality where you click here, there are some extra panels opening, and you can just basically simulate what kind of rainfall event would happen. For example, if you use the RCP 4.5 scenario, you want to have an event which has a return period of 25 years in the year 2070. You click simulate, and you will see it will enter a value, rainfall value for you to use. For example, 34 millimeters. Here, there's two other interesting things that we allow you to do. First of all, there's an infiltration parameter set. So as Christina explained, we use different cyan values, which relate to the infiltration. And we have 4 different, let's say, standard sets, which are explained here as well, depending on the soil structure in your area. Or again, you can use a custom one. So for example, here I have created a custom parameter set and I can select it here if I would want to. I will just use a standard one. And secondly, we also allow you to simulate, if you would like, some blue-green infrastructure scenarios. Here, we allow you to either select no scenario or the 3 scenarios that Christina discussed. So for example, I will use the buildings to green roof scenario. And then if I click calculate, it will calculate your area. So what do we see here? So there's a bit of different coloring, but the logic is the same. Of course, we're in a very, very dense area, and we have used a very extreme rainfall event. So you see that all the houses that are located here basically have a problematic runoff problem, which makes sense, of course, because it's a very, it's not a permeable surface at all. So you can see that here. We also have one value. You see the circle itself, for example, area of interest, is shown also in red, which also is a calculation basically of the whole area. So not just for each individual building, but also for the whole area, which explains, okay, this whole area itself also has a problematic problem. Now, we can also open our data panel here, and you see it is quite similar to the previous one. What we show here is the amount of runoff we expect for the whole area, as well as the different building risks, the different risk distribution for the buildings. You can see that basically 100%, I think it's, no, apparently there's one building that's not, but every other building is in the problematic category, as you can see here. I do not have another area, not other calculation in this area, so I cannot start a comparison scenario just yet. I think this is the most important features of the application. So I think we can go back to the presentation then, I assume. I will stop sharing my screen.
Thank you very much, Tis. And then please correct me, Tis and Christina, if I'm wrong, but we will send to the participants the link after these webinars and a small guide on how to get into the application and how you can try it for yourselves. So you can also go in your own time through the application, through these services, through this service and the functionalities that things explain. Also, you will have this, so it could also be as a refresher for you to understand the service. So for next session, we have the question and answers. If we go to the next slide. And I ask you to please send us if you have any questions or raise your hand if you would like to have a more like a conversation. In the meantime, I have a couple of questions already, so I'm gonna go with them, but for the rest of the participants, please write your questions in there. So our first question for, I guess, Tis and Christina, any of you who feel like responding, it would say, from what we've seen today, the tool seems very useful. How exactly can it help authorities make better plans to prevent flooding?
Maybe I can give this insight. This tool can help identify the areas that are problematic, because this methodology is not so detailed that we would analyze that with this tool in deep. But this identify that buildings or areas that needs to be providing by actions in priority. So that in this way, it supports the informed decisions for activation the actions.
Perfect. Thank you, Christina. I see we have also one raised hand. I'm gonna give them the floor. Matej, I'm gonna allow you as well. And you should be able to tell us your question, please.
Okay. Hi, can you hear me? Yes.
Yes.
Okay. Hi, my name is Matej Redinia. I come from University of Ljubljana, so I live in the case study area. I have a question. Well, it kind of relates to the last answer that Christina said. So actually, you calculate the surface runoff, and based on that, you determine if the area is problematic or prone to flooding. But as you said, yeah, I guess this depends on the sewer system and capacity of the sewer system. So also if we have a high runoff, but if you have a sewer system with a good capacity and if it leads to a nearby river, then maybe this is not problematic. So maybe it would be nice also to include like the maximum runoff or the volume of runoff so that the stakeholders could use this information to check with their infrastructure if it can handle such runoffs. Otherwise, yeah, I think it's a very nice project and a very nice tool, and I'm looking forward to using it and testing it.
Yes, thank you, Matej. I agree, and we want to do this in CLIMRES project because here we want to include the, of course, pre-calculated runoff volumes and to offer the users also this model data. But for now, yes, we stopped only on the surface runoff. But thank you. Yes, we are continuing in this way, including additional parameters to provide even more decision supporting tool.
Okay, thank you very much.
Thank you both. I see we have another question in the chat. It says, how do you calculate the damage per building? Do you take a percentage of the value of the building, or how do you determine the percentage?
I will answer this question. The calculation is based on first floor area and expected damage per square meter. And the expected damage was is from the original method that was developed for Slovenia, and is based on previous flood damage. On previous floods, we have a huge database of events that happened, let's say for 20 years back, and we take those damages, exact damages that were, and we did statistics upon that, and that's the base. But because it was developed for Slovenia, we added the functionality that each user can change parameters. So let's say for some city in Germany, for sure the expected damage per square meter will be higher than in Ljubljana. So we offer the end user that he change it, but he need to know what's the statistic and the methodology behind. So.
Maybe I can also quickly add on that. The tool will actually look at the flood extent as well as the building footprint. So if the flood extent, for example, only covers about 20% of the building's footprint, it will also assume that only 20% of the building is flooded. So it will take that into account. So it is of course a simplification. But it does not assume that if it's only for 1% flooded, it's flooded the whole thing. No, it's just like it actually looks at where the flood extent is.
And also we need to be aware that it's statistical simplification. So if someone will choose only one building, the result is not, let's say, the result is, let's say, for minimum 5 buildings. So for each particular building, it's statistically not a good result. So it's for, let's say, for neighborhood, for half of the city, and not for a specific building. So it's a method behind.
Okay, thank you both. I know we're running a bit behind of our schedule, but we have one last question that I think would be also relevant to answer. So it's a bit long. It says, to use the tool in another city, what kind of local information or data would we need to get started? And would this tool be something that both technical experts and regular municipal staff could use, or would it need a lot of training to understand?
I think maybe I can quickly start on that from a data point of view. So what you basically need is a flood extent. So you will need to know where your flood will be. So we do not include any complicated hydrological modeling and so on, because that's just too heavy as well for an online tool. So you will need to have some data about your flood extent, and that's basically it for the flood damages, at least. The building layer is a possibility. If you would like to calculate damages for buildings, of course, you need to update the building layer, but you can also just use the Urban Atlas cover, which is provided anyway. So for that, the only actual really condition is your flood extent. And then for the urban runoff mode, there you don't technically need any data at all. So it will work at any place where the Urban Atlas cover is available. But we feel that the results are more relevant if you include the building layer there. So there would be better, I think, to also upload a building layer. But so these are the only 2 data sets you actually need, let's say, for it to work. And then I don't remember the second half of the question, sorry.
The second part of the question was regarding if if this tool can be used by both technical experts and regular municipal staff, or it would need a lot of training to understand the tool.
Maybe that's more for Christina or Petra to answer.
I can answer. Our purpose is that anybody can use this. We really wanted to provide user-friendly tool with some technical instructions that we provided also in a guide that will be shared. Can work with this and can understand also the results by these rich visualizations.
Thank you very much, all of our three speakers today who answered the questions. Now I would like to go to the next slide. Before we finish this training, I would like to ask you to please fill out this very short survey. This will help us also to understand the value of the project itself. So I'm gonna copy the link in the chat as well, so you also have it there. If not, please scan the QR code and answer these questions. If you have had previously the chance to go through the service, please answer yes to the first question. If you haven't had the chance, please answer no. And as we said before, we will send the link and a few step-by-step on how to use the service. And we will send you again this service so you can answer to the first question again. But please, I ask you to take a few minutes of this now, just a couple. Or you can also follow our social media and our website. We are continuously updating information about the activities of the project in there. If you would like to be part of the other training sessions regarding the other services that that Buildspace is developing, please look at in your website, or you can contact us directly through our email as well. So I think for now we can close out this session. And if we go to the next slide, please. So thank you again, everyone, for taking the time today and for joining us today. I think we have seen how Buildspace is not only advancing on energy efficient, but also to making cities become more climate resilient through these tools like Service 5. This pilot shows how data, technology, and local collaboration can come together to tackle real-world challenges, like in this case, urban flooding. And we hope this session has inspired you to explore how these solutions can be adapted in your territory if you are a local stakeholders, or if they can replicate it also in your own other context. We currently have an open call for application feasibility for those who would like to assess how to use Buildspaces in your context. So I invite you to go to our website. And if you're interested in learning more or staying connected with the project, please don't hesitate to reach us out. Thanks again for your time and engagement, and we look forward to keep having this type of conversations with you. Thank you for joining us, and this is the end of the training session. Thank you, everyone, and have a good day.